whichever cracking equations you write, and you're going to tell me what your answer is. You can't do it mentally, though some of you can, but it's good to do it on copy. That way you can eradicate the mistakes sometimes we do when we're going with the mental calculation. Are we ready?
Yes, sir.
Okay.
Yes, sir.
So if you have the copies in front of you, before we get started with the equations on your side, let me revise the equation we did yesterday. Take a look at the starting equation. Decane in the presence of heat and catalyst gives us octane and ethene. Now, doing it mathematically is quite easy. As you can see, the number of carbon atoms over here in decane is 10. And number of carbon atoms are exactly balanced on the other side of the equation. Take a look. We have 8 carbon atoms in octane and 2 in ethene. 2 plus 8 is equal to 10. So that is simple arithmetic, right? Hydrogen on the left-hand side is 22 atoms, while adding up whatever we have on the right-hand side, 18 plus 4, we get 22. So that's quite simple, right? So let's start with the questions. Your first question. You have nonane as a reactant, nonane, C9, I mean. It's an alkane, so hydrogen atoms are खुद ही लिखेंगे. In the presence of heat and catalyst, it is going to give you hexane plus an alkene. I don't know what the name of alkene is. I don't know its formula. You're going to do it on your own on the basis of simple arithmetic.
So alkene?
Yes. Nonane
Also,
in the presence of heat and
reactant?
catalyst, that is C9. Nonane, C9. That is the reactant. In the presence of heat and catalyst, it is going to give you 2 products. One of them is an alkane, which is hexane, that is C6, right? And the other one is an alkene, ENE, I mean doubly bonded compound. So I don't know the name, I don't know the formula. You're going to come up with the answers. And the person I will ask the specific question, please tell me the specific answer. Do not come up with the whole equation. Okay? Just tell me the part I asked you. Right? When anyone is done with the complete equation, let me know so that I can start with the questions. I can write it down for you here. What we have is nonane, right? And in the presence of heat and catalyst, of course, it is going to be converted into hexane, plus it gives an alkene. We don't know what the alkene is. You're going to tell me that. So that's the equation right in front of you. Today, we're not going to start with girls. We start with girls every time. So today, we're going to start with boys. Let me pull up the participant list and let me see who I can start asking the question.
Sir, proper नाम होगा. Propene.
Shazib, quiet. Until unless I ask you the question, not going to answer me that. But let me start with you. As you've already answered a bit of it, so I'm going to ask the same thing. So yes, Shazib, you're correct. It's propene. But Shazib, you're going to tell us its molecular formula.
C3H6.
C3H6. All right. Let's come to Wase. Wase, what would be the molecular formula for hexane?
C6H14.
Good. And Tanisha, beta, what is the molecular formula for our reactant over here? Tanisha, if you can hear me or if your mic's working, fine. If not, if anybody's mic is not working like Kabir's has, so they can always answer in chat. I don't mind. You can always come up with the answer through chat. That's fine. But please send it to everyone, not just to me privately. Nisha, beta, can you hear me?
Yes.
So, beta, what is the chemical formula, molecular formula for nonane? I already told you the number of carbon atoms are 9, so you're only supposed to tell me the number of hydrogen atoms for it.
C9H20.
Very good. Okay, Ayan, Next question is for you. Ayan, did we need any balancing numbers for this equation? With any of
No,
the
sir.
substances? Good, good. Okay, next equation. Let's erase this one. Let's go for a new one. This time we are taking the decane that is written over there. So it's not going to be a problem for you to find the molecular formula. I'm not going to ask that question, of course. And the product is once again hexane. I'm not going to ask you that. But this time it produced ethene. Next question is from Rafe. And after Rafe, we'll have Kabir, Zaim, and Zoha for a question. Okay? Rafe, your turn, beta. Rafe, what would be the balancing number used in this equation? Because there is definitely a balancing number involved. And which substance will we put it with? What's the number and which substance will we put it with? Rafe.
सर मैं बताऊं
नहीं, Rafe, can you hear me, beta?
यस सर
हाँ जी.
सर इथिन के साथ हम लगाएंगे
And what's the
Balancing.
number, beta? What's the number that we will put with ethene?
सर 2
Very good. We're going to put 2 with ethene. And that's correct. Okay. Kabir, you're up next. Kabir, for you, what we are going to do is that we are going to change the situation a little bit. That goes for Kabir, Zaim, Zoha, all the students who haven't answered yet. Okay. For you, beta, for all of you, let's come with the second possibility we had over here in the pink portion. In the pink portion, the second bullet point says that an alkane might give you 2 or more alkenes and hydrogen. This time an alkane upon a cracking reaction will not give an alkane. Okay? So let's start with Kabir. Let me write the equation for you, Kabir. Kabir, you are going to decompose decane, of course, and it produces an alkene, then another alkene, a different alkene, not the same one, plus it produces hydrogen. Okay, so beta, you are going to tell me, okay, the entire equation, step by step. Now, this is an open-ended question, Kabir. So whichever alkene you make from it doesn't matter. I mean, it's completely your choice. Carbon 3, carbon 4, carbon 10, carbon 20, it's all up to you. You're going to tell me the whole equation in the terms of molecular formula, also in the term of names. Kabir, take your time to write it in the chat. Okay? And till Kabir is writing that up in the chat, let's come to a question for Zoha. Ji, Zoha beta. Zoha beta, for you, there is a small change in the equation. You're going to go with the same equation, but this time, one alkene is specified as ethene. What would be the equation, the entire equation? Zoha beta, take your time to come up with the equation and then answer the question. And who's left? I think only Zaim's left, right? Zaim, you ready?
Yes, sir.
Zaim, this time it's the same equation, beta, but there is a simple change in it. You're going to tell me the entire equation. Zaim, in your case, we're also going to need some balancing numbers. So you're going to tell me what the numbers are and which substance are we going to use the numbers with. So there we go. We have all the questions for Kabir, Zoha, and Zaim. Whoever is ready may come up with the answer first. Okay, I have a text in chat. Let's see. Kabir's answer go to everyone. So let me ask a question from Ayan. Ayan, is Kabir correct?
सर एक मिनट देख रहा हूँ.
Sure, take your time. It's okay. Wase, same question from you. Rafe, same question
यस
from
सर
you.
सही है. सही है सर.
What's Wase's opinion?
Yes,
What's Rafe's
yes sir,
opinion?
ठीक है sir.
सही है सर.
ठीक है. What about Rafe? Shahzeb, I also need your opinion.
सही है.
ठीक है, good.
सही है सर.
Good.
सही है.
Acha. Okay, Shahzeb, another question from you. Shahzeb, there are 3 products in order. The first product, the second product. Of course, the third one is the easiest, hydrogen. So, Shahzeb, you're going to tell me the name of the first product. Which Kabir wrote, I mean.
So, butene.
Butene, very good, Shahzeb. And Nisha, this one is for you. Nisha, beta, what is the name of the second product for the equation Kabir wrote?
Ethene.
No, beta, for what Kabir wrote in chat, not what I wrote. Tanisha, beta, you need to pull up the chat. There is an equation that Kabir wrote to everyone. There are 3 products in that equation. The first one is butene, according to Shahzeb, and he's correct. The last one is hydrogen. That is very simple. You're going to name the second product for us. Take a look at the chat and then let us know. And Zoha, Zain, you may answer it anytime. That's fine. Ji, Tanisha, Zain, Zoha, we are waiting for you. Come on, quickly. Zain, बेटा आपकी आवाज नहीं आ रही. आपका माइक ऑन होता है लेकिन आपकी आवाज मुझ तक नहीं आती. Repeat.
So C10H22 is equal to 2C4H8 plus C2H4 plus H2.
Very good. Good work. That means I have got a complete grasp on it. Good work, Zain. What about Zoha and what about Ayan? Wait. What about Zoha and what about Nisha? Beta, you need to come up with answers. Nisha, beta, if you're confused, or Zoha, if you're confused, you can always ask for help. That's fine. अगर आपको किसी जगह पे confusion हो रही है, ask me the question. I can answer it for you, or I can help you. ठीक है? We are here for this purpose. ताकि ये questions एक दफा आपकी grasp पे अच्छी हो जाए. उसके बाद whether it's the first scenario alkane forming alkane, or it's the second scenario alkane forming only in kenes, you can always come up with the correct answer, right? Come on, quickly. Let's not waste the whole class's time. We're waiting.
Hexene.
जी जोहा आप क्या कह रहे हैं बेटा? Can you repeat?
Hexene.
Okay, जोहा आपने तो निशा का आंसर दे दिया बेटा. आपने तो मैं पूरी इक्वेशन बतानी थी. All right, but Tanisha beta, Zoha has answered the question for you, and good work, Zoha. By the way, that's correct. Okay. Let me tell the whole class that the way Shahzeb answered or the way Zoha answered, okay, that's correct. Beta, whenever a molecular formula is written, you can't come up with the whole isomer name. Why? Because the isomer is not clear to you. Now, C4H8 can be but1-ene, it can be but2-ene. We don't know. Why? Because we don't have the structural formula. Without the structural formula, you cannot come up with the exact isomer name. And if you cannot come up with the exact isomer name, you need to come up from the molecular formula. From seeing the exact molecular formula, you can only come up with a generic name. So Shahzeb never said but1-ene or 2-ene. He simply gave the answer butene, which is correct. Because मॉलिक्यूलर फॉर्मूला आपको सिर्फ जेनेरिक नेम तक लेकर जा सकता है. एग्जैक्ट नेम के लिए आपको हमेशा ऑर्गेनिक केमिस्ट्री में एक स्ट्रक्चर चाहिए होता है, चाहे वो एक्सपैंडेड स्ट्रक्चर हो, कंडेंस्ड हो, CH bonds drawn हो ना हो, that doesn't matter, but you need a structural formula to get up to the exact name of the isomer. And if you don't have that, if you have the simple molecular formula, you can always come up with a generic name. So we don't know it's but-1-ene or 2-ene, but butene is correct. So Shazib answered correctly, and well done. And the same goes for Zoha. She also answered correctly. Now we don't know whether it's hex-1-ene or hex-2-ene or hex-3-ene. These are all possibilities. We don't know. There are even more possibilities than that. Hexene के केस में हमारे पास roughly 8 different possibilities isomers की बनती हैं. ठीक है, मैं सारों के नाम नहीं ले सकता इस वक्त बैठकर, लेकिन sorry, 9, not 8, 9. ठीक है, तो whatever the case may be, in the case of isomer, what we need to come up with is the generic name as soon as we see the molecular formula. Now, the case would be entirely different if instead of molecular formula, we have as a question the structural formula. Then you need to come up with the exact name. And the same goes for your exams. ठीक है, आपको examiner के क्वेश्चन के पैटर्न से ये आइडिया लगाना होगा कि वो आपसे क्या पूछना चाह रहा है. If only molecular formula is given, you can only come up with a generic name. But if there is an entire structure drawn for you, do come up with the exact IUPAC naming by numbering everything and by putting the numbers in names. Okay? Like we've done in chapter number 10. I hope that's clear for the entire class. Is it?
Yes,
Yes,
sir.
sir.
Okay. Now, one last case that we still need to discuss. And who's going to answer? Wase is going to answer. Wase, think wisely and let me know if the scenario exists. I'm going to explain a scenario to you, and you're going to tell me whether it can exist or not. There was a cracking reaction which actually went with the second outcome. And the second outcome, according to the pink portion of the book, is that we got 2 or more alkenes and hydrogen. Can this happen that an alkane, when went through a cracking reaction, can give only one kind of alkene and hydrogen? Is it possible? Yes or no? You can simply answer us with yes or no. Let me repeat the question. If there is an issue with understanding portion, okay, or any kind of imaginations for you, can there be a possibility that an alkane is cracked and it gives only one alkene and hydrogen? Yes or no?
Yes, sir.
Yes, very good. So, Vase, let's consider, and I'm extending my question, let's consider the equation that I wrote last and gave to Zoha enzyme as an example. I'm going to edit that equation a little bit for you. Let's, in the case of decane, think and let me know the name of the alkene which would be produced if we talk about the exact scenario I just asked you a question from. If anyone has the answer, do not tell us the answer.
C10H20.
Sorry?
The C10H20.
No, that's not possible. Remember, it
Sir,
gives a
नहीं
shorter.
होता. Sir,
No.
नहीं हो
Vasi was
सकता.
actually right. The possibility does exist. उसमें वासी ने mistake नहीं की. उसपे तो मैं इसलिए appreciate कर रहा था वासी को क्योंकि वासी ने correct answer दिया. So think which alkene can it be? And it has to be a shorter chain. आप C10 के alkane से C10 का alkene नहीं बना सकते. Remember, all cracking reaction gives a shorter chain. उसने वो second point में नहीं लिखा है, but first and second point are definitely connected. Anyone? Now, I'm not just asking Wase. Anyone in the class, if is able to answer the question, please come up with the answer. And you can go for wild guesses. I don't mind. Come on. You need to be a little creative.
Ethane.
Hmm? No, actually no. It has to be an alkene, not an alkane. जी राफे?
नोनीन और ऑक्टीन नोनीन
नो,
और
सिर्फ
octene.
एक alkene बनाना है. बैलेंस कैसे होगी इक्वेशन? Nonene equation balance नहीं होंगी. Rafi, you're going in the right direction, but your answer is not exactly correct. You won't be able to balance the equation like that. Rafi, come up with the answer in the same direction, but try to also balance the equation at the same time. Only then your answer can be completely correct. Remember, every equation that you come up with in exams, you need to come up with the equation in a balanced form. Without that, you don't get your marks in exams. So that's the
So
possibility you can't reject.
2C5.
Yes,
So
please.
2C5H10.
Perfect answer. Love that, Zaim. Did everyone get the idea from Zaim that what we are doing over here?
Yes, sir.
So basically, the idea
Yes,
is
sir.
to break the chain in exact half. And that's pretty much possible only with alkanes, the reactants, if they have even number of carbon atoms. If they have odd number of carbon atoms, of course, we'll have two different alkenes as a product. Only if C10 is broken into C5 in two proper halves, we all, of course, are going to need a balancing number for that equation. Okay? C8 into C4, C6 into C3, C12 into C6, like that. Do you get the point?
Yes, sir.
Good, good. And good work, Zaim. I really appreciate that. Okay, so continuing, this was the work we were supposed to carry on from yesterday, because this was very important that you understand the cracking reactions. They are a part of past papers, and recently IGCSE has been focusing on cracking reactions as important question in exams. See,
सर केमिस्ट्री का पेपर चेंज हुआ है सिलेबस?
अभी तक तो नहीं बेटा. They're planning on changing, which they said back in May, but अभी तक हमारे पास कोई update नहीं है. But I haven't checked in recent 5 days. I checked it last week. So मैं आज या कल में दोबारा check कर दूँगा. अगर आपके पास कोई ऐसी news है, I'll check it again.
सर मैथ का चेंज हो गया.
मैथ का हो गया. Then there might
sir.
be chances with other science subjects. We'll look up to that. ठीक है? कोई मसला नहीं. I'll look into it. अच्छा किया आपने बता दिया. Okay, so continuing. I hope we are completely done with cracking, and the most important part of cracking is the definition of cracking, the possible outcomes, writing the equation. One more important part of cracking is that they consider the cracking conditions, which are given in the very first paragraph of this page. This is page number 279, and that has been the most important question in past 10 years. The conditions of cracking. In past papers, you'll find this question far more in number than the balancing of equations, cracking equations. All right. Now, let's come to a little more pieces of information before we wind up this cracking topic. Both products, I mean, the alkanes and the alkenes are useful. The shortened alkanes can be blended with gasoline fraction to enrich the petrol. What happens if we enrich the petrol? What is blending? We'll discuss that in the very next topic. Okay, on the next page, page 280. Okay, so I'm just going to skip explaining this line because there is an entire topic for it. The alkenes are useful as raw materials to make several very important products. Okay, figure 11.6 shows various uses of ethene. This is also on page number 280. Let's go to that figure. Take a look. Ethene is one of the most common products of cracking. No matter what kind of possible outcome there is, the chances of formation of ethene are much more than all other alkenes, right? So ethene is very important when it comes to producing other important products used in our life. What we are already done with is the first reaction of ethene, that is with steam. Remember, this reaction was of ethene and steam at 300 degrees centigrade at 60 atmospheric pressure with a catalyst in the immobilized phosphoric acid form. Immobilized, by that I mean the phosphoric acid in liquid form was actually absorbed on this leaker pellets or barium sulfate surface, right? And in that case, we formed ethanol, ethanol of a far greater purity than we can produce from fermentation, right? And this ethanol is industrially used a lot. Then there are three more reactions in which the first, second reaction over here, or the first polymerization reaction gives us polyethene or polyethene. What is polyethene? How is it is used? You might be familiar with the name. We'll discuss that in the later part of the chapter. In the second half of the chapter, we'll discuss all these three reactions. The formation of polyethene. The next one is formation of chloroethene or vinyl chloride. And the last one is reaction with benzene in the formation of phenylethene or styrene. We'll discuss all three of these in the second half of this chapter. And continuing with the polymerization, vinyl chloride can be converted into polyvinyl chloride, which is commonly known as PVC. We'll discuss that too. And styrene is can polymerize into polystyrene. We'll discuss that too. Okay? So all five of these products, the entire portion, the bigger 80% of this diagram is to be discussed in the second half of this chapter. It's just names that we need to go with over here. All right. Do not try to memorize the names because we're going to discuss them in detail. And after discussing the details, you'll automatically memorize them because there are entire pages in explanation of each one of these products. All right. Any questions from this diagram?
सर बस करें यहीं पे
नहीं थोड़ा सा और इस टॉपिक को खत्म करना है. This is a cracking plant in oil refinery. It goes for the cracking under the specific conditions as we mentioned, under the temperature in the catalyst, and it goes for further subsequent distillations to separate specific products. Okay? And the last paragraph, propene polymerizes to polypropene, trade name polypropylene. Butene polymerizes to synthetic rubber. Synthetic rubber is commonly used even in students' life. Student life में बल्कि हम rubber, synthetic rubber ज़्यादा use करते हैं निस्बतन किसी भी adult की life के. वहाँ pencil, rubbers, play-doh इस तरह की बहुत सारी चीज़ों का use होता है. That has made a lot of polymerization from butene, the exact product synthetic rubber, and the byproducts in the form of play-doh and stuff. ठीक.